Welcome to Pravdan Tutorials. Please kindly subscribe. Thank you.
Welcome once again to Pravdan Tutorial. So today at the end of this lesson, you will be able to differentiate a function of this type, which is still a logarithm function. So in our previous video on how to differentiate a natural logarithm function written as y equals ln x, for example, or ln of ax, we did say that the differentiation of this is simply 1 over x. If you remember, in general, we say if you have y equals ln of a function of x, then we infer that its differentiation is going to leave you with differentiate that function x, which is written as f prime x, over we write the function x, which is f of x. Okay, one thing I didn't mention in that video, which I'm going to tell you now, is that this natural logarithm function is the same, can be written as logarithm to base e of x, that is, or ln x, or log x. So when the base is not indicated, it is assumed that it is to base e, or when the base e is there, it is the same as ln x. So when you have this type that is written to base e, if it is specified, it is what we call the Naperian logarithm. But then our focus today is, what if the base is given as a number? Okay, for example, this base a. So this is what we're going to be looking at today. Okay, so quickly, let's say we have something like this. Log x base a, for example. So in this case, the base is specified. It is not e, it is not exponential, it is not a Naperian logarithm. So where in this case we can say let's say our a is greater than 0 and the same a is not equals to 1. So then how do we differentiate this type of logarithm function? So this is our focus for today. So in general, let's say we have y to be equals to log to base a of a function of x. Then its differentiation will be f prime of x, that is, differentiate that function of x, okay, over, then you have, we write the function of x, okay, and multiply it with ln of the base a. Is as simple as that. So you can see that the difference between this and the previous one on natural logarithm function is the ln a that we have. As you can see here, look at this. So the difference now is just the addition of ln a. So just take note of this. So guys, let's look at some typical examples to have better understanding of how to do this. So in general now, so what it means is that from the dy ds for this, dy ds for this, my dy ds is going to be equals to, following this procedure now, f prime of x. So if I differentiate x, what do I get? I get 1 over, we write the function of x, it is ordinary x, I rewrite it, then you have ln of the base is a. So this is our answer. Okay, so with this understanding, we can quickly look at some examples. So looking at this example is as easy as applying it just straight away. This is a logarithm function to base 10 of the function 3x squared minus 5x plus 2. So don't forget, all you just have to do is the y, the x is going to be equals to f prime of x. So in this case, our f of x is the whole of 3x squared minus 5x plus 2. So f prime of x, differentiate this, you have 6x minus 5. Okay, so over, we write the function, which is 3x squared minus 5x plus 2. Then don't forget to put lane of the base. The base in this case is 10, so you have lane 10. You can apply chain rule to also solve this. Very easy. So we're going to look at another very good example. And example 2, we've got this. Okay, so identify your function of x, which is this. So this is a fraction in this case. So our function of x is 2x plus 1 over x plus 2. In our video on this type of differentiation, that's when we talk about quotient rule. So you have to apply quotient rule to be able to differentiate this easily. I can still use cover-up method and get my answer quickly, but as a way of revision, remember that in quotient rule, all you have to do is identify the numerator as u and the denominator as v, and you need to know your du, ds, differentiate the numerator, and that's going to give you, if you differentiate the numerator in this case, 2x will be left with 2, and 1 is a constant, which will be 0. So my answer is 2. I also need to differentiate my v with respect to x. When I differentiate x, I get 1. And when I differentiate the constant, so it will be left with 0. So this is our result. And remember, in general, what quotient rule says is that you have v, the denominator, differentiation of the numerator minus the numerator, differentiation of the denominator, divide the x, all over v squared. So quickly just substitute all you've got. V, our v is x plus 2, du dx, which is 2, minus u, we have 2x plus 1, dv dx, which is 1, all divided by v squared. So we have x plus 2 all squared. So simplify this further without wasting time. So if we simplify further, 2 multiplies everything inside this bracket, and you use this negative to multiply all of this, we'll be left with this. And so from here we can see that 2x minus 2x will give us 0, then plus 4 minus 1 is 3. So this leaves us with 3 over x plus 2 all squared. So this is just for our f prime of x. Okay, so apply the general rule for differentiating a logarithm function to base a. So remember, the y dx for this type of function, we did say previously is going to be f prime of x over f of x multiplied by ln of a. In the case of y is equals to log base a f of x. Okay, so in this case, let's apply what we've got for this example. We have f prime of x. Let's put it inside as 3 over x plus 2 all squared. So we have this divided by, we have f of x. F of x is 2x plus 1 over x plus 2, f of x being multiplied by ln a. And what's that gonna be? Ln of a. Our a in this case is 5, so we have ln of 5. So if we go ahead to simplify further, we can have 3 over x plus 2 all squared multiplied by, then we inverse this. It's going to leave us with x plus 2 over 2x plus 1 ln 5. So the whole of this can cancel one of these, so we'll be left with 3 over x plus 2 2x plus 1 ln 5, and you can still simplify further if you so desire. Alright guys, that's gonna be the end of today's tutorials. I wish you all the best. Please kindly subscribe to Prof Dan Tutorial. Thank you, and see you in our next series of video. Bye bye.
Please kindly subscribe. Thank you.